welcome back to our Quality Mantra Decoding Series. I'm Vimala Balusamy, Quality and Project Management Consultant for Mega Construction Projects and Corporate Management. In this episode, we are going to discuss about the field change errors. It's one of the critical topic in construction. This occurs when the work executed on site does not match the approved documents. Approved documents? Yeah, the blueprints like drawings. Many times, teams get confused between design and field changes. Yes, while reviewing contractors' documents, I have also pointed that out where changes were wrongly categorized, especially when they had an impact on time and money. Okay, let me give some simple example. Consider a scenario in metro rail station construction involving the installation of a CCTV camera. The objective is to capture the entire view of the station. During installation, only half of the station is covered due to the elevator's position, which blocks the remaining view. So the team decides to reposition the camera to a location where it can capture the complete view. This requires only minor cabling adjustment with zero impact on cost or schedule. The revised cabling route will be recorded in the as-built drawings. Okay, fine. This is a field change. It involves no design change, no cost impact, and no schedule impact. Fine. Now, in the same scenario, if the team cannot adjust the camera to get a full view and shifting the elevator becomes necessary, this would be a design change as it involves cost, time, and rework.
Nope, this idea is an expensive and infeasible.
Since the structure is already built, relocating the elevator may not be feasible, right? Instead, installing additional cameras at different locations be the ideal solutions. However, this leads to increased cost, extended time, and changes in cable layout, system integration, right? So all of which fall under a design change. I hope this clarifies the difference between these two. We already know it after multiple site visits and a thorough evaluation of all parameters, especially geotechnical reports. It includes soil investigation reports, underground utility services, and analyzing the risk parameters, the past parameters, right? It involves multiple activities, all of which are part of a typical feasibility analysis that confirms the structure can be built as planned. Fine. Still, the field changes occur. Why? Let's break down why they occur and more importantly how to avoid them with real world examples. I have issued multiple NCRs during my site audits specifically for this issue, not using the latest approved GFC, but for construction drawings. Many times the site team had no idea about changes, even though updates were shared via email by the design team. As a result, the team continued working with the outdated versions, which led to rework and variation claims. So, how to avoid this? Ensure immediate sharing of latest drawings digitally. There are multiple tools are available in this AI era. Almost all the companies are generating their own project management solutions, or they adopt some mechanics like BIM. There are so many options are available. So this update in real time and notify designated distribution groups promptly. This distribution group is nothing but the communication matrix. So there are different every project. Generally, it's a list of members like structural team, MEP. So like they have different groups. The mega project cannot be bombard all the drawings to one team, right? So whoever required it will go appropriately to the designated team. That's called distribution group. This is generally managed by the document control department. Next point is issued control hard copies. Generally, we used to issue A1 size drawings to the relevant site team. They get the signature, all this okay. But this should be as per the distribution matrix. Whether we call communication matrix distribution matrix, the important point is it must be maintained accurately. Yes, that's the third point. Keep distribution groups up to date. In a dynamic project environment, the site team must coordinate proactively with the document control team or PMS team to update the matrix and ensure drawings reach the correct people. Okay. The fourth point is DC team coordination with design consultants and stakeholders. They should act as a point of contact from all types of consultants and the stakeholders. So they should be aware about the changes at site or design teams or whoever. So they should inform if it is some like changes at site or in charge. Then they have to give the information to the design consultants and other relevant parties of any matrix changes. Okay. This ensures that design team communicate drawing revisions to the appropriate site personnel. For example, if it is taking some time to update the IFC or GFC, they communicate via email. So it will avoid variation. So before starting any work, the site supervisor must verify drawing status and confirm the current revision he is working on it. His team is working on it. This is very important point. Okay. The second point is negligence of site conditions. This is another common error that occurs frequently. This is exactly the kind of situation the site team ends up in when the design team fails to consider actual site condition in their drawings. Design team must visit the site and collaborate closely with the relevant stakeholders before finalizing drawings, even during construction, as I mentioned earlier.
This is a classic example of what happens when design is done in isolation. Without understanding the actual site conditions, the design team failed to consider real-time site conditions. On paper, it looked fine. But on site, the layout didn't match the alignment, resulting in a disastrous field change. This kind of error stems from poor site investigation, reliance on outdated survey data, or designing remotely without ground validation. The result? Rework, delays, safety risks, and a loss of trust in quality assurance. The solution is simple but critical. Design should always be validated on-site, and collaboration between field engineers and designers must be non-negotiable.
Field changes often arise due to lapses in combined services drawings or interface drawings. These drawings are typically developed by the MEP or rail system consultants who collect inputs from various stakeholders. However, even one stakeholder delays or provides incomplete input, the drawing remains unfinished. As a result, clashes occurs during execution, forcing the site team to adjust fittings and fixtures on the spot as much as they can. Any misadjustment could result in major reworks and delays. So, conduct regular coordination meetings and establish a single point of contact for drawing updates. Use digital collaboration tools like, as I mentioned earlier, PMIS or any other corporate software to ensure real-time communication and alignment across all teams. Field changes also happen due to sequence lapses, especially when multiple contractors work in parallel without synchronized planning. In mega construction projects, parallel execution is essential, but it demands accurate sequence diagrams, typically prepared by the site coordination manager. Somewhere they are calling it as interface manager. They collect all inputs from all contractors. Here is a real-world example from metro rail construction that shows how a sequence lapse can trigger field change.
In construction, timing is everything. One small delay can snowball into costly chaos.
So the solution is prepare detailed dynamic sequencing plans with built-in buffers and real-time updates. Always confirm the sequence with contractors before starting each phase. Implement a clear coordination schedule. From experience, like Hyderabad Metro project, I have seen how tough it is because the environment is constantly changing. Delays are happens, but the team responded diligently thanks to the proactive efforts of the PMC, who ensured all contractors coordinated, shared inputs, and revised their schedules. Last but not least, inadequate design inputs. Field changes due to inadequate design inputs. Let's say the architectural team finalizes the roof layout of a metro station platform, but during the design phase, drainage input from the plumbing contractor is either missing or only partially incorporated. Just an example, okay? I'm not pointing to any particular contractor. The approved GFC drawings show the roof slopes and locations of downpipes, but on site, the actual slope and pipe outline locations don't match up because the plumbing layout wasn't fully developed or coordinated. Result: the civil team finishes the roof slab based on approved GFC, but when the plumbing team arrives to install the downpipes, they discover the outlet are not aligned with the roof slopes. Water will accumulate instead of draining, leading to ponding or seepage risk. So, the site team now has to core new holes, reroute pipes, or adjust slopes, all outside the original design. These changes cost time, money, and may even affect structural elements like beams or ceiling finishes. If there are not much changes with the design, then it's a field change or it may become a design change as well. So ensure that design inputs from all relevant disciplines, civil, structural, MEP, rail system, power, are fully received, coordinated, and validated before issuing drawings for construction. In project like metro rail or high-rise buildings, the mega project, the incomplete inputs in early design stages can lead to costly rework on site. Peer reviews and class deduction software to catch errors before construction begins. They generally prepare class deduction schedule, so there are so many documentation I have seen it, but still it all happening at the site. Are there any regulatory standards related to field changes? In general, all changes must be regulated through a change control board, which should be established by the organization with a defined authority matrix. This board typically reviews proposed changes and either approves or rejects. We will discuss about this with detail in another quality mantra. Any change that triggers cost and or time subject to the variation process. Right? Because on-site due to ad hoc schedules, most field changes are approved at the site level, which I feel it is necessary. It cannot be dragged for the approval process. But the approver has to ensure he coordinated with the right stakeholders like design team to ensure it does not have any impact on the structure. Okay? Depends on, like if changing the camera, it's not going to make any changes. Like depends on that. So the quality manager must ensure that appropriate procedures and relevant formats are developed and used by the team. The process should clearly define how field changes are managed on the project. So I have listed these points based on my experience with the previous projects, but there are certainly other factors that can trigger field changes. If you think of any, please share them in the comments below. Field changes are inevitable in construction, though we love to avoid 100%. If it happens, we need to define the process that how to manage them. A discipline approval process, not just for big design changes, but also for smaller field adjustments, ensures transparency, accountability, and control. This keeps cost overruns and delays in check and safeguards quality. Sometimes field changes are expensive, but still they are avoidable. By improving communication, verifying designs thoroughly, and using modern tools, we can save time, money, and lot of headache. Remember, every approved change is not just a formality, it's a commitment to doing things right the first time and building trust across the entire project. Thanks for watching.